Can you see the screen? Can you see the screen?
Yes, sir.
Okay.
Sir.
Yes, sir.
Now we start the lecture algebra 1. Okay, instead of differential equation. So in the previous lecture, we seen that what is the definition of cyclic group, cyclic subgroup, and permutation and some theorems related to cyclic group. Now we will discuss what is the homomorphism. Okay, homomorphism, isomorphism. Okay, and the fundamental theorem of okay algebra. Okay, fundamental theorem of algebra. First isomorphic theorem. Okay, then we will see the first isomorphic theorem. Okay, so once again, good afternoon all. Okay, now what is mean by homomorphism? Okay, a function which preserve the operation is known as homomorphism. Okay, which preserve the operation means what? If suppose a function phi from set A to A is a function, okay, which is which preserves the operation, which means suppose G is a group, okay, suppose G is a group and the function is from G to G, okay, we take domain and codomain as a G, okay. If function phi is a function from G to G such that on G, suppose the operation star is there, okay, G star is a group, okay, then the homomorphism means the preserve the operation. It means the phi of A star B is equal to phi of A star phi of B. Third year ला असताना आपण प्रूव्ह केलेलं आहे. Homomorphism means which preserves the operation. Okay, homo means same. Okay, the structure of domain and codomain with respect to that binary operation must be same. Okay, फक्त दिसायला ते वेगवेगळे एलिमेंट असतात पण त्यांचे सगळे प्रॉपर्टीज हे कसे असतात सेम असतात. ऑल द प्रॉपर्टीज आर of domain and codomain are same. Okay, now the next definition is what is the isomorphism. The definition of isomorphism, the function which is 1 1 and onto. Okay, the function which is 1 1 and onto homomorphism is known as isomorphism. The two more conditions are inserted in the homomorphism. Okay, the function which is 1 1, that means 1 to 1 correspondence, and onto every element in the codomain there is a pre-imaging domain, and also the homomorphism is known as isomorphism. Okay, this is the definition of homomorphism and isomorphism. Now the next definition is, in this lecture we will see the more definition. Okay, so the join of H and K or H union K. Okay, the join of two subgroup. If suppose let H and K are two subgroup of G. Okay, let H and K be two subgroup of G, then the join of H and K we write like this. Okay, H dot K is equal to small h into K, small k, where H belongs to capital H and small k belongs to capital K. Okay, and this notation is also called as product of two subgroups or join of two subgroups. Okay, every element in that group, every element in that set must in the form of H dot K, where H belongs to capital H and K belongs to capital K. Okay, and H union K, and H union K is the smallest subgroup of G which contain both H and K. Okay, the smallest subgroup of G which contain both H and K, H union K. Okay, the next definition is coset. Okay, what is mean by coset? Suppose H is the subgroup of G and A belongs to G with any element. Okay, then the coset h into a. Is it a right coset or left coset? कोणता कोसेट आहे हा? राईट कोसेट कोणता आहे आणि लेफ्ट कोसेट कोणता आहे?
First one is right coset and second one is left coset.
Sure.
Yes, sir.
Okay, very good. So first one is the right coset. H dot A is equal to small h into A, where h belongs to capital H. Okay. And or this is the left coset, small a into h, which is equal to A into h, where h belongs to capital H. This is the definition of right coset, and this is the definition of right coset, and this is the definition of left coset. Okay. Now the index of h in G. Okay. The h, if h is the subgroup of G, the index of h in G. Okay, index of h in G we can write like this: order of G by h. That is equal to order of G upon order of h. And this is nothing but index of h in G. Okay. Suppose G is equal to set of integer. Set of integer with operation plus. Okay, आता जर z म्हणलं, G is equal to z म्हणलं की ऑपरेशन कोणतं येणार? प्लस येणार. ते अजून करायचं तुम्ही आता. हा, and suppose h is the set of even integer. Okay, h is the set of even integer. So what is the index of h in G? What is the index of h in G? What is the order of G? It's infinite. है ना? Please mute your Google Meet. Okay, mute करा सगळेजण. If G is set of integer z plus and h is the set of all even integer. Okay, so h is the subgroup of G. Then what is the index of G in h in G? Anyone know? Find kara. Okay. Order of G.
Order of h.
Order of G.
Divisor of order of h.
Divided by order of h. So what is the order of G here? Set of all integers with addition. Infinite ना?
Elements in.
म्यूट करा. आधी आपला बाकीचे कोण बोलते बाजूला त्यांनी म्यूट करा. जे बोलणार आहात ते चालतं. Okay. Order of G is infinite. Order of H is infinite. Okay. But index of H in G is 2. Okay. Cosets किती येणार त्याचे एकूण? Index of H in G is nothing but number of cosets ना? One more example let's take. If G is finite, okay, G is finite. Quaternion group माहिती आहे तुम्हाला? Q8 plus minus 1 plus minus I j k with multiplication. Okay, quaternion group. माहित आहे का नाही?
Yes, sir.
Quaternion group. The number of elements in quaternion group Q8 is equal to
8.
8. And H is the take H is equal to plus minus 1. Plus minus 1. Then what is the index of H in G? 8 divided by 2.
4.
Sir, someone has not muted their self, so it is disturbing.
Please mute all the students. Wait for Wait a minute. Megha Kali, please mute your Google Meet. Okay. Megha Kali. Okay. Wait a minute. If G is the quaternion group and H is the plus or minus 1, then what is the index of H in G? 4. Whether this statement, the index of G in H for infinite group, is it possible? Is it true? If G is infinite group, whether this statement is true or not. For example, G is equal to set of integers and H is equal to set of even integer, which is the subgroup of G. Then what is the index of H in G? Infinite upon infinite, you can't find now. But the index of H in G is 2. There are two cosets exist, okay, for set of even integer and set of integer, okay. So now next definition is that normal subgroup, okay. A subgroup H of G is the normal subgroup of G if G inverse is equal to H, okay, or G inverse G is equal to H, and it is denoted by H is normal in G, okay. If suppose G is the abelian group, G is the abelian group, whether all the subgroup of G are normal or not. समजा G जर abelian असेल तर त्याचा प्रत्येक सबग्रुप हा नॉर्मल असतो का नाही? abelian म्हणजे काय? तो कम्युटेटिव्ह प्रॉपर्टी सॅटिस्फाय करतो. ग्रुपची डेफिनेशन काय सांगते आपल्याला? A subgroup H of G is the normal subgroup of G if G inverse is equal to H. ओके, ह्या G inverse ला काय करायचं? राईट हे करा, काय म्हणतात त्याला? हे नथिंग बट काय? G inverse is equal to H is nothing but all the right cosets and left cosets are equal. GH is equal to HG ना? पोस्ट मल्टिप्लाय करा G inverse ने, काय होणार होतं? G न इथं आयडेंटिटी येणार आणि इकडे HG येणार. So GH is equal to HG. Hence all the right cosets and left cosets are equal. It means the G commute with every element of H. All G belongs to G. For abelian group, the subgroup of abelian is also abelian. Hence, H must be abelian. Okay. So the every element of every subgroup of G is the normal subgroup of G. Okay. This is the one more remark is there. Every subgroup of G, abelian group G, is the normal subgroup. Okay. Then the next definition is that conjugate subgroup. Okay. What is the conjugate subgroup? If two subgroups are there, H and K are the subgroup of G, it is said to be conjugate subgroup of G if H is equal to G inverse K G or H is equal to G K G inverse for all G belongs to capital G. Okay, हे खूप महत्त्वाचं स्टेटमेंट आहे बरं का. डेफिनेशन कॉन्जुगेट क्लास इक्वेशन पुढे जेता येईल ते हे सगळं उपयोगी येतो. Okay, so H is equal to G inverse KG or H is equal to G KG inverse for all G belongs to G. Okay, then we say that H and K are conjugate subgroup. Okay, if this condition satisfies, then we say that H and K are conjugate subgroup of each other. Okay. So the next definition is that quotient group or factor group. Okay. G upon n is equal to n into A, where A belongs to G. Okay. Okay. So n is the normal subgroup of G. Whether it is possible that if n is not a normal subgroup of G, then can we find the G by n? Whether n is a normal, not a normal subgroup of G. Okay. Can we find n G by n? Tell me. तुमचा रिस्पॉन्स महत्वाचा आहे खूप बरं का, नाहीतर या ऑनलाईन लेक्चरचा काही उपयोग नाही. The necessary condition is that n must be a normal subgroup of G to find G by n. Okay. So G by n is equal to Na, where A belongs to G. So every element of this group, factor group, okay, this factor group is in the form of n into A, where A belongs to G. And the necessary condition is that n must be normal subgroup of G. Okay. This is called as factor group or quotient group. Now the next definition is simple group. Okay. The simple group means that does not exist. This is the symbol of does not exist. Okay. There does not exist any proper normal subgroup of other than capital E. Yes, sorry, singleton E. Okay. There does not exist any proper normal subgroup other than singleton E. Then that group G is called as simple group. If suppose G is a group, so there does not exist any proper normal subgroup. Proper means what? Properly contained in that group. Okay, G. H is, suppose H is a normal subgroup of G, then H is contained, okay, contained in G, then not equal to G, but not equal to G, then H is called proper normal subgroup. Okay. But in here, in simple group, there does not exist any proper normal subgroup of G other than singleton E, because singleton E is a normal subgroup for any group. Okay, singleton E is a normal subgroup for any group. Okay, so except than this, there does not exist any proper normal subgroup. Okay, then that group is called as simple. Okay, या सिंपल ग्रुपशी संबंधित सायलो फर्स्ट थेरम, सायलो सेकंड थेरम आणि सायलो थर्ड थेरम, 3 सायलो थेरम आहेत. ओके, जे फर्स्ट चॅप्टर मध्ये आहेत तुमच्या आता येणाऱ्या सिलेबस मध्ये. द मोस्ट इम्पॉर्टंट स्टेटमेंट थेरम्स. ओके, these are the most important theorems to find the simple, the group is simple or not. Okay, एखादा ग्रुप दिलेला आहे तो सिंपल आहे का नाही हे शोधण्यासाठी सायलो थेरम वापरतो, ते आहे पुढे. ओके, सो नोट, the next is note, if the group is cyclic group, okay, every cyclic group is abelian group, which implies if group is abelian, then every subgroup of that group, okay, every subgroup of that group must be normal. Okay, by previous remark, then there exists a group now which is proper and normal, hence that group is not a simple group. Okay, if whenever G is a cyclic group, it implies that that group is not simple. Okay, whenever the group is abelian group, then that group is not simple. Okay, understood? Second statement, every cyclic group is not a simple. Okay, and third statement is that every group with prime order is not a simple. Okay, every group, we know that every group with prime order is a cyclic. प्राइम ऑर्डर असेल तर तो सायक्लिक असतो, सायक्लिक असेल तर तो अबेलियन असतो, अबेलियन असेल तर त्याला प्रत्येक सबग्रुप काय असणार? नॉर्मल असणार.
नॉर्मल.
ओके, हेन्स द ग्रुप इज नॉट सिंपल. ओके, अंडरस्टूड? नाउ द नेक्स्ट part is commutator element of A and B. Commutator element. Let us say what is commutator element. An element A, B, A inverse, B inverse is called a commutator of A and B in G. Okay. Suppose we have two elements A and B, then you have to find the commutator element of A and B, which is equal to A, B, A inverse and B inverse. Okay. For example, look at here. If G is equal to 1 minus 1 I minus I. Take A is equal to I and B is equal to minus I. Then what is the commutator element of I and minus I? Look at here. The commutator element of I and minus I is A. What is A? I. B. What is B? Minus I. A inverse means I inverse and B inverse means minus I inverse. Okay. So I as it is, minus I as it is, inverse of I. What is the inverse of I?
Minus I.
Minus I. Why?
I.
Why? The inverse of I is minus I. How?
I into minus 1 is I 1, sir.
Okay, the product of these two is 1. Okay. And product of, the inverse of minus I is I. Hence, I square into minus I square, which is equal to minus 1 into minus 1 is equal to 1. So that the commutator element of I and minus I is 1. Okay.
1.
So now tell me what is the commutator element of 1 and I? Solve it and tell me now what is the commutator element of 1 and I?
One and minus I.
1 and minus I. Take 1 and minus I. A is equal to 1 and B is equal to minus I. Tell me the commutator element.
I.
1 and I, sir.
I, sure?
I and 1.
Yes, sir.
Sure?
Minus 1.
Minus 1, sir.
Minus 1. Okay, the inverse
Minus
of
1.
minus I is I. So product of I and minus I is minus 1.
Minus 1.
And minus 1 into 1. Minus 1 into 1.
Minus 1.
Minus 1.
So that the commutator element is minus 1. Okay. The next definition is that normalizer of a set S in G. Okay, the normalizer of element is a different and normalizer of a set is a different. Okay. So let's see what is the normalizer of a set S in G. Okay. The set of element in G which commute with each element in S is the normalizer of S in G. Okay, what it means? Look at here. N of S, which is normalizer of set S. The set of element in G which commute with each element in S. It means N of S is the subset of G. Okay, N of S is a subset of G. By definition, it defined like this: X belongs to G. असे एलिमेंट घ्या X मधून जे S च्या प्रत्येक एलिमेंट सोबत कम्युट झाले पाहिजे. Take X from G, which commute every element of set of S. Okay, such that X belongs to G such that S is equal to Sx for all S belongs to capital S. It means every element in S, the X is commuted. Okay, or X inverse is equal to S. Post multiply by X inverse. Then here X and to X inverse we get E, and here X inverse. Okay, so X inverse is equal to S for all S belongs to S. This is the definition of normalizer of a set. Okay. Now, next definition is normalizer of an element. Okay. The normalizer of an element in G and the normalizer of set S. These are the two different parts. Okay. So we see, so what is the normalizer of an element, which is denoted as n of A. Okay. So A belongs to G. Okay. Take any element A belongs to G. Then normalizer of A is equal to X belongs to G such that XA is equal to AX, where so that E belongs to NA always. Why always? Look at here. E is committed with every element in a group. Okay. E हा element प्रत्येक element शी काय करतोय? Commit करतोय. Hence E is always belongs to N of A. Understood? If A belongs to G, then N of A is equal to X belongs to G, where XA is equal to AX. म्हणजे ह्या A ला त्यातला एक एलिमेंट घ्यायचा A. G मधून एक A हा एलिमेंट घ्यायचा आणि या A लाच कोणकोणते एलिमेंट कॉम्बिनेट होतात ते या सेट मध्ये घ्यायचे. Hence N of A is also subset of G. Okay. N of A is also subset. And furthermore, N of A is also subgroup of G. Okay. Subset तर असतोच पण तो subgroup पण असतो. Okay. So tell me, what is the biggest set? If S is a set here and here A is the element, हा set मोठा असेल का हा set मोठा असेल? Whether N of S is bigger or N of A is bigger. कोणता set मोठा असेल? N of A मोठा असेल का N of S?
N of S.
N of?
Because A is elements and S is the set of elements.
S is the set of elements. Okay. So bigger is what?
N of S is bigger.
N of S. Sure?
Yeah.
अजून कोणी आहे का? अजून कोणी सांगू शकते उत्तर? Tell me, who is bigger, N of S or N of A? N of A is bigger ना, because here only one element is there ना. फक्त एकाला कमिट होणारी मोठा असेल, इथे सगळ्यांना कमिट व्हायला पाहिजे. म्हणजे इथे रिस्ट्रिक्शन जास्त आहेत तुमच्याकडे. ओके, अंडरस्टूड? रिस्ट्रिक्शन जास्त आहेत, प्रत्येक एलिमेंटला कमिट व्हायला पाहिजे इकडे, आणि इकडे एकाच एलिमेंटला कमिट झालं तरी चालेल. ओके नाही? अंडरस्टूड? इथे रिस्ट्रिक्शन जास्त असेल तर येणाऱ्या लोकांची संख्या कमी असेल इथे, आणि रिस्ट्रिक्शन इथे कमी आहे, फक्त एकाच एलिमेंटला कमिट व्हायला पाहिजे. मग इथे येणाऱ्या लोकांची संख्या काय असेल? द नंबर ऑफ एलिमेंट्स फ्रॉम G is bigger than N of S. Okay, so hence N of A is the bigger. Okay, understood or not?
Yes, sir.
Okay,
Yes,
so
sir.
N of A is the bigger set. Now the next theorem is that the statement. Look at the statement. बात काही ना लक्ष द्या खूप. Okay, if G and G dash are the groups, two different groups are there. Okay, G and G dash are two groups, and a function phi from G to G dash, and phi dash is the function from G dash to G, where phi and phi dash is homomorphism. Homomorphism means it preserves the operation. Okay, it preserves the operation. Then all these four statements are holds. What are these four? Look at here. If H is the subgroup of G, it implies phi of H is the subgroup of G dash. Look at here. If H is the subgroup of G, means in the first phi from G to G dash, na? So image of phi of H in the G dash. Okay, the image of H is in the group G dash. Hence, this phi of H is the subgroup of G dash. Second statement, if G is the normal subgroup of G. If group is there, then also the image is also subgroup of G dash. Here, the H is the subgroup of G, then the image of H also subgroup of G dash. Normal subgroup of G dash. Okay. If subgroup is there, then image also subgroup. Each image is a, if H is the normal, then phi of H, the image of H is also normal in G dash. Okay. And third statement, if K dash is the subgroup of G dash, if K dash is the subgroup of G dash, it implies phi dash of K dash is the subgroup of G. Image कुठे येणार phi dash of K dash G? G मध्ये येणार. Okay. So image is in the G. Okay, so phi dash of K dash is the subgroup of G. And fourth statement, if K dash is the normal subgroup of G dash, it implies phi dash of K dash is the normal subgroup of G. Okay, phi dash ची image कुठे येणार? G मध्ये येणार. And phi ची image कुठे येणार? G dash मध्ये येणार. Okay. Now the next part is first isomorphic theorem, the most important theorem. Okay, one of the most important theorem, the first isomorphic theorem. इथून तुमचा सिलेबस चालू झालेला आहे. ओके, हे सगळं बेसिक कन्सेप्ट होते आतापर्यंत. Now the syllabus is started. Now the first isomorphic theorem. Okay, let G and G dash be the group. Okay, let G and G dash be the group, and F from G to G dash is the function. Okay, that is F from G to G dash. G dash is a onto homomorphism. It's onto homomorphism. Then G dash is isomorphic to. This is the symbol of isomorphic. Hence, the theorem is called first isomorphic theorem. Okay. Then G dash is isomorphic to factor group of G upon kernel of F. Okay. You know kernel. Kernel. What is the meaning of kernel? Kernel of a function. माहिती आहे का kernel of function म्हणजे काय? Suppose F is function from G to G dash. Then kernel of F is the subset of G or the G dash. माहित आहे का कोणाला? If kernel of F is the subset of G or the G dash, kernel of F is the subset, and furthermore it is a subgroup of G. Okay, subgroup of G. Kernel of F is nothing but the elements in G such that the mapping, it maps to the identity of G dash. Okay, असे एलिमेंट घ्यायचे. कर्नल ऑफ एफ म्हणजे असे एलिमेंट घ्यायचे ह्या जी मधून जे या जी डॅशच्या आयडेंटिटीला मॅप करायला पाहिजे. ओके, इथं आहे डेफिनेशन. कर्नल ऑफ एफ इज नथिंग बट take the elements from G such that f of x is equal to E dash. Hence, kernel of F is the subgroup of G. Okay, understood?
Yes, sir.
Okay, so let F from the given, we have to prove that this theorem, isomorphism. For isomorphism, we have to prove first 1, 1, on 2, and what? What is the definition of isomorphism?
1, 1 on 2 homomorphism.
Okay, good, very good. The function must be 1, 1, also on 2, and also homomorphism. So we have to prove 1, 1, on 2, and homomorphism. Okay, so let f is the function from G to G dash is onto homomorphism. Okay, why onto homomorphism? We consider that it is a onto homomorphism. Okay, and kernel of F is the normal subgroup of G. We have one more note or remark. Kernel of F is always normal subgroup of G. Why? Because to find the this factor group G upon kernel of F, you have to be kernel F must be normal in G. हा जो खालचा जो ग्रुप असतो की नाही तो must be normal subgroup of G असायला पाहिजे. Okay, hence the kernel of F, you have kernel of F is always normal subgroup of G by previous theorem, where kernel of F is equal to x belongs to G and f of x belongs to E dash. F of x is equal to E dash. Why this is by previous theorem? Kernel of F is the subgroup of G. Okay. Why? Previous theorem म्हणजे कशावरून म्हटलंय previous theorem हे मागे पाठी बघितलं नाही तर. Here, if y is the G to G dash is a mapping homomorphism. If H is the subgroup of G, then phi of H is the subgroup of G dash. Okay. किंवा नोट आहे आपल्याकडे या वैशिष्ट्याचा कोणताही अल्जेब्राचं टेक्स्ट बुक घ्या, त्याच्यामध्ये कर्नल ऑफ एफ इज ऑलवेज सबग्रुप ऑफ नॉर्मल सबग्रुप ऑफ जी. Okay, not a subgroup, always normal subgroup of G. Okay, so here's the definition of kernel of F. Kernel of F is nothing but taking x from G where f of x, the mapping of that x, it maps to identity of G dash. Okay, hence we find that G upon kernel of F, G by kernel of F is the quotient group. Hence we define like this. Okay, जर हा kernel of F जर नॉर्मल असतोच तर हा खालचा कोणताही सबग्रुप जर नॉर्मल नसेल, so we cannot find G by that capital H. G by H is quotient. Okay, for quotient group it must be have to the normal subgroup. Okay, so let G by kernel H, assume this G by kernel H is equal to n, then n is normal subgroup of G. Okay, now sorry, kernel of F is equal to n page now. Sorry, here the printing mistake is there. Let kernel of F is equal to n. Let kernel of F is equal to n. Then n, that kernel of F is normal in G. Okay. Hence, we define a new function psi from G by n. This n is nothing but kernel of F. Here n is equal to kernel of F, not G by kernel of F. Okay. So psi is equal to, psi is the function from G by n to G dash, and the element of the this group, this factor group, which is in the form of n by ng. Okay, sorry, ng. The element from this group is in the form of ng, where this G belongs to capital G and n is nothing but normal subgroup, which is kernel of F. Okay, such that define this function like this: gamma of, sorry, psi or gamma of ng is equal to f of G, and this f of G is from G dash. Okay, हा f of G कुठून असेल? G dash मधून असेल. फंक्शन आधी नीट समजून घ्या. जर फंक्शन कसा डिफाइन केलेला आहे हा समजल्यानंतरच तुम्हाला 1 1 ऑन 2 आणि होमोमॉर्फिझम प्रूव्ह करता येईल. आपल्याला फंक्शन f हे ऑन टू होमोमॉर्फिझम दाखवायचं आहे. You have to prove this f is onto homomorphism. Okay, with the help of this gamma. Okay, this gamma, we define this gamma like this: gamma of ng is equal to f of G. The every element of G dash is in the form of f of G. Why f of G? Because f is the function from G to G dash, and f of G belongs to this G dash. Okay, hence we define like this: gamma of n G is equal to f of G. Now we have to prove this gamma is well defined and 1 1. Okay, what is mean by well defined? Well defined म्हणजे काय? तो फंक्शन आहे हे आपल्याला आधी प्रूव्ह करायचं आहे. आपण हे डिफाइन केलेलं आहे असं, पण हे फंक्शन आहे का नाही माहित नाही आपल्याला अजून. ओके, so we have to prove this function gamma is well defined and 1 1. Okay, for well-definedness, we have assume that the image of, okay, we have let n of n into G1 is equal to n into G2. N G1 is equal to n G2. Okay, for well-defined, we have to prove that the gamma is well-defined function. We assumed that n G1 is equal to n G2. Okay, this is the process for proving the well-definedness. Okay, so this G2 post multiply by G2 inverse, then this n G2 becomes n G2 into G2 inverse, which is nothing but E, and n into E is equal to n. This is the identity n, and this n G1 G2 inverse. Okay, which implies an implied G1 G2 inverse belongs to n. Why? Again, this is the basic concept, but G1 G2, if HA is equal to H, suppose you have HA is equal to H, then that A belongs to H. माहित आहे का? है हे नोट माहित आहे का तुम्हाला? HA is equal to H. If HA is equal to H, then A belongs to H na? By that note, G1 and G2 inverse belongs to N, but N is equal to kernel F, which implies an implied if this element belongs to kernel of F, it maps the identity element of this G dash. Okay, so G1 G2 belongs to kernel of F. It means that it maps the image of this element belongs to A dash. But F is what? Onto homomorphism, na? But F is onto homomorphism. Okay. We have assumed that F is onto homomorphism. Onto homomorphism means what? It preserves the operation.
It preserves operation.
Okay, so F into G1 G2 inverse is equal to E dash. It means F of G1 into F of G2 inverse, which is equal to E dash, where this E dash belongs to G dash, which is the identity of G dash. Okay, so F of G1 into F of G2 inverse. पुन्हा हे सगळे बेसिक कन्सेप्ट आहेत बघ, काही थर्ड इयरला झालेले आहेत, तुम्ही प्रूव्ह केलेलं आहे. G2 inverse, which is equal to F of G2 inverse is equal to F of G2 bracket inverse. Okay, whole inverse असतो, माहिती आहे ना? F of G1 into F of G2 whole bracket inverse is equal to E. By again multiplying, post multiplying by F of G2, then we get F of G2 inverse into F of G2 is equal to E dash. These are the elements from G dash now. So we get the identity element of E dash. Hence, F of G1 is equal to F of G1 into E dash is equal to this E dash into F of G2. Hence, we get F of G1 is equal to G2, implies and implied. All the statements are implies and implied. Hence, F of G1 is equal to F of G2, but F of G1 is nothing but gamma of n of G1 by the definition. Okay, by like this. Okay, by this statement, we define like this: F of G1 is nothing but gamma of n of G1 is equal to gamma of n of G2. Thus, gamma is well-defined function and one-one function. Okay, gamma is well-defined function and one-one function. Implies and implied कसं करणार? ह्याच्या उलट जर गेलो तर आपल्याला 1 1 मिळेल, बरोबर ना? खालून जर वर गेलो आपण तर काय मिळेल आपल्याला? 1 1 मिळेल. आणि वरून जर खाली आलो, implies and implied statement, all the statements are implies and implied. Hence, thus this gamma function is well-defined function and one-one function. Now we have to prove that this gamma is onto. Okay, this gamma is onto. Let y belongs to G. Onto means what? Onto means what? We have to prove this gamma is onto function. It means that every element in G dash, you have to be prove there is a pre-image in G by n. Okay, प्रत्येक एलिमेंट G dash च्या प्रत्येक एलिमेंट साठी मला काय पाहिजे? G by n मध्ये मला एलिमेंट मिळायला पाहिजे. Okay, म्हणजे onto means काय, range of that function is nothing but whole codomain. Okay, now you have to do that this gamma is onto. For this, let any element belongs to G dash. Then there exists G belongs to capital G such that f of G is equal to y. Okay. जर मी एखादा एलिमेंट G dash मधून घेतला तर डेफिनेशन ऑफ द फंक्शन f काय मिळणार मला, देयर एक्झिस्ट बाय दिस डेफिनेशन. By this definition of function, if G dash belongs to this group, if y belongs to this G dash, then we get onto homomorphism. Now this function f is onto. We are assuming that this function is onto. Hence, every element of this G dash we get pre-image in G. Okay. So by the definition of f, we get every element in G dash, there exists element G belongs to capital G such that f of G is equal to y. Okay, by the definition of f, since f is onto function. Okay, thus for this G belongs to G, for this G belongs to G, okay, we get NG, the right coset. Okay, NG means right coset, which is belongs to G by N. Okay, for this same G, जो काही मला हा एक्झिस्ट झालेला G आहे त्या G साठी मला काय मिळेल, N into G मी डिफाइन करू शकतो, which is belongs to G by N. Okay, and hence for this y is equal to f of G belongs to G dash, there exists G belongs to G and NG belongs to G by N. Okay, या y साठी मला काय मिळाला, एक स्मॉल g मिळाला आणि त्याच स्मॉल g बरोबर मला काय मिळाला, एक NG मिळाला, which is belongs to G by N. Hence, for every y we get NG, such that gamma of NG is equal to f of G, which is equal to y. For every y we get image NG, every element NG, which is belongs to G by N. Hence, gamma is onto. Okay, hence gamma is onto. Now we prove that the gamma is 1 1, the gamma is onto. Now we have to prove that gamma is homomorphism. Now to prove that homomorphism, that is to prove that gamma of n of G1 ng1 into ng2 is equal to gamma of ng1 into gamma of ng2. Okay. Now for this, let us assume now gamma of ng1 into ng2 is equal to ng1 ha into hb. What? HAB na? By this definition of right cosets, we write like this, ng1 g2. Okay, by the definition of right cosets, ha into hb is equal to hab. Hence, gamma of ng1 into ng2 equal to f of g1 g2. By the definition of gamma function, we write which is equal to f of g1 g2, but f is onto homomorphism. Okay, by the definition of f is onto homomorphism. Then f of g1 g2 is equal to f of g1 into f of g2, since f is homomorphism. Okay, but by the definition of gamma, again in reverse mode, f of g1 is nothing but gamma of n of g1. Okay, by the definition of f g1 and f g2, f of g1 and f of g2 here. By f of g1 is nothing but gamma of ng1 and f of g2 is nothing but gamma of ng2. Okay, hence which is equal to gamma of ng1 into gamma of ng2. Hence, from statement number 1, 2 and 3rd, give it as equation number 3rd. From 1 to 3, we write like G by N. Okay, that function, gamma function, is isomorphic function. Okay, isomorphic functions mean what? This gamma function. So G by N, this gamma function is 1, 1, onto and homomorphism. It means G by N is isomorphic to G dash. Okay, which is nothing but our statement. G dash is isomorphic to G by N, but N is nothing but kernel of F. Okay, so here we prove that the first isomorphic theorem. Okay, कोणाला काही doubt आहे का? So G by N is isomorphic to G dash, that is N is nothing but kernel of F. So G by kernel of F is isomorphic to G dash, and which is nothing but first isomorphic theorem. समजते? आपल्याला हे स्टेटमेंट प्रूव्ह करण्यासाठी एक फंक्शन डिफाइन करावं लागेल जो असेल गॅमा. कळतंय? विथ द हेल्प ऑफ फंक्शन एफ. ओके, 1, 1 onto homomorphism, it nothing but isomorphism. समजते का?
Yes, sir. Yes, sir.
Yes, sir.
जर समजलेलं नसेल तर पुन्हा युट्यूबवर व्हिडिओ आहे त्याचे. ओके, so today we seen that the first isomorphic theorem. So in the next video we will see the next part. Okay, इथून तुमचा सिलेबस चालू झालेला आहे. कोणाला काही डाऊट असेल तर तुम्ही मेसेज करू शकता व्हॉट्सअप वर. ओके, चालेल? जर ग्रुप वर करता येत नसेल, ऑड वाटत असेल तर पर्सनली करा, काही अडचण नाहीये, पण तुम्हाला हे समजणं अधिक महत्त्वाचं आहे. Okay, this is the first isomorphic theorem. Okay, thank you. The next part we will see in the next lecture. So now you can leave.